Hi guys, in this video I'm going to cover variable types or primitive data types. So whenever we declare a variable, we have to provide a data type followed by an identifier and then a semicolon. So the data type defines what values can be stored in that variable. And the identifier is a variable name that we use to identify that variable. And then the semicolon ends the statement. So it ends the statement to tell the computer to create this variable or to allocate memory for this variable. So the most or the smallest data type is of type bool. And here I create a variable is valid. So this variable can hold values of either true or false. So these are truth values. We can, for any variable that we create, we can always update the value, we can store a value, we can change it later and update it, we can read that value. So it's a location in memory where we can store values. And the data type defines how large that location needs to be. So if we store really large numbers, it needs to be bigger than if we just store true and false, for example. Now another type is integer. So integer stores numbers, in this case whole numbers, and in this case we can store a really large negative number, we can store smaller negative numbers, 0, and positive numbers, and large positive numbers. Now this is typically 32 bits long. If you need anything larger, there's a larger type, such as long. And this is typically 64 bits integers. And since we have long, we also have short. This is typically 64-bit integers. Now these are the integer types. Then we have a character. So a character can store, for example, in this case I create a variable of type char where I store letters in it, or I name it letter to indicate this will store letters. But a character really can be anything. It can be from A through Z, can be uppercase A through uppercase Z, and we can store any type of characters of signs in there, such as question marks, hashtag, whatever we want to store in it. And we can also store numbers. For example, 4. Now it's important that when we store 4 as a character, and when we use it in general in our program as a character, it's different than the number 4. The number 4 is really the number 4 that we think of and that we can perform arithmetic operations on. When we have the character 4, it's really just another character. So 4 is no different to the computer than hashtag or A. It's just a character. So the computer by itself doesn't recognize 4 when it sees 4, or we interpret this as a number. It's really just another character. Now also important to mention is that all these characters have some kind of encoding. So for example, an ASCII encoding, where it's an integer code that represents this character. And that code is not necessarily the 4. So if we would perform an arithmetic operations on this character 4, it would likely perform the operation on the ASCII code or the encoding itself, and we would get weird results. So we want to be careful that we define the data type for a variable, that we use the appropriate type that we want. We don't want to create a variable of type char to store numbers in it. Now another type is float. So float will be used to store floating point numbers in it. In this case, I call this variable fraction, since I want to store a fraction in it. So this can be, again, positive, for example, 0, negative 0.382. It can be just 0 itself. It can be a positive number. So really can be any kind of fractional numbers. Again, it's 32-bit long typically, but we could use double to make it more precise. So in this case, I call the variable precision. This one be typically a 64-bit floating point number. And then we have another data type, string. Now this is not really a primitive data type, but it's often used just like a primitive data type. In reality, it's a class type. And strings is used for text. So we can store something hello world. And the way, well, what a string really is basically a sequence of characters, right? I have here the character H, then followed by the character E, followed by the character L, and so on. And I could even store a single character as a string. Or, in fact, I can store the number 4 as a string. Now again, a 4 by itself is the number 4. A 4 in single quotes is the character 4, and a 4 in double quotes is a sequence of a single character, and the character is 4. So it's still a sequence. It's just one character long, but it's a difference. It's different when we have 4 in double quotes versus 4 in single quotes. Since this is a sequence and this is not a sequence, that's just the character itself. Now for many of these, we also have signed, for example, signed int, call this value. This one is, since we have the sign, negative and positive integers. And then we have unsigned, and this is just positive integers. So for many of them, like float, double, and so on, we have signed and unsigned type. And why would we bother with it if we can just leave it out? So the reason is that when we, for example, don't care about negative values, but we need to represent large positive numbers, we don't need to waste that space that we have. So to simplify it, let's say our data type can represent 20 values. Now we could say we want to represent values from -10 until positive 9 or positive 10 to represent the 20 values. To keep it simple, let's just say -10 to positive 10. Or we could say we want to represent from 0 until 20. And if we don't care about negative numbers, but we do want to represent the larger numbers like 12, 15, 18, up until 20, we could just say we want to use an unsigned type to represent that. So I hope this gives you some ideas. In the beginning, I would just focus on these types, and when you become more comfortable, you may want to look into signed and unsigned when the program requires this. So thank you for watching.